So here's a lab I did with my Chemistry 30 class. It is to get the enthalpy for the combustion of magnesium. So starting off with, because it's a Hess's Law lab, we do have our target equation, which gives us magnesium solid, adding in some oxygen, which is a combustion reaction, to get magnesium oxide. Now this is an exothermic reaction, and instead of measuring just heat though, it also releases light energy, so we have to account for that. So for this reaction, what we can do is 2 calorimetry experiments, plus take the formation enthalpy of water and use Hess's Law long to figure out the enthalpy of the reaction. So here's just that equation one more time, and then just showing what we have. So I know this is a bit hard to see, but this is just a strip of magnesium, and then we're adding in that flame, so oxygen, and when we're done, this white powder here, we have magnesium oxide. Now this is just a picture showing that when it is burning, you are getting that light coming off of it as the reaction, and you're also losing heat. So we can't capture that, so we don't know the delta H of this reaction, but we can figure it out. So what I have here is the data collected if we did 2 calorimetry experiments, one with magnesium oxide and reacting it with hydrochloric acid, and then measuring that temperature change, which was a change of 7 degrees, and then figuring out the delta H of that reaction using the calorimetry formula. The other reaction was with a strip of magnesium reacting the same way with hydrochloric acid, and then getting that temperature change, figuring out that delta H. And then the last one is just knowing the heat of formation of water and getting that from our data booklet. Once you have that, then you have the enthalpies of 3 equations, and we can start to manipulate those equations. So what the point is, once you can calculate these lab values and then get this one from the data booklet, then we can start to rearrange our equations to get this target equation and then add our enthalpies together. So for instance, equation number 1, I need to flip because I need MgO as a solid on my product side. So I'd have MgO solid plus 2HCl to give me, I wanted to flip this reaction. I'm just starting to write it down again. Let me just grab the eraser here. So let me try that again. So I'm flipping that reaction. So I have H2O plus the MgCl2 to give me MgO plus 2HCl. Now, because I flipped this reaction, I would want to make this value positive. Moving on to the next one, I have Mg as a reactant, and I want it as a reactant. So I'm just going to write this one down once more, how I see it. And I didn't do anything with this one, so I would just keep that value again as I see it. And then this last one with water. Water is not in my target equation, but what I do have is water in my first equation as a reactant. So because it's not in my target, I do want it to cancel. So I'm just going to keep this one again as is so that I see it as a product, and that way I can cancel it. So because I kept it as is, this value would stay the same. So now things will start to cancel nicely, right? The water cancels, the 2HCl cancels, the hydrogens will cancel, and MgCl2 cancels. What you're left with is magnesium, which we have here, half an oxygen, which we have here, and your product, magnesium oxide. So that is what we would get if we added all 3 equations together with everything canceling. And then if we add all 3 equations together, we can also add in our delta H's. So if I do that from the previous slide and I added all my delta H's, this is what I would get, negative 575.04 kilojoules per mole. Now with that, that would be considered my actual value or my lab value, whereas the accepted value, and you can just get this from the data booklet, is negative 601.6. So this would be my theoretical value. So if I'm calculating my percent error in a very, very simple way, I would write actual minus theoretical divided by theoretical, the absolute value of this, and then multiply it by 100%. So let's do that quickly because I don't have that one ready for me. So I'll just have to stick that in my calculator. So I have 5.04 subtract my negative 601.6, and I want to, oh, what did I do wrong here? Actual, sorry. Divided by theoretical, and then times it by 100. So I am getting a 4.4% error, which is pretty good. And then we want to talk about it. So at the percent error, because it is telling you how wrong you are, the closer to 0, the better. The higher it is, the worse your lab went. But this is decent. We could probably make it better by trying to make sure our calorimeter was sealed a little bit better, that reaction took place, all of that, but that's really the end of it. So I hope you found this helpful. If you did, please subscribe, and if I could do any other video for you, just let me know. And if you want to see the lab when you actually do combust magnesium, please check out my short. Thanks for watching.